everyone? Chapter 8, Learning Target 3. This is Miss Ozier.
And Miss Lahart.
And here we go. Arithmetic series. So now we're using a different word. We're not using the word sequence, we're using the word series. A series is the sum of all of the terms of a sequence.
Mm-hmm. Yeah, sum. Yeah. Series.
Ooh, hey, Siri on my phone came up. Given an arithmetic series, the sum is given by doing this, okay?
Wow.
So this formula you are not given.
You have to memorize this formula.
You need to know it. So
Hey guys, you need to memorize that formula.
you're not given this one.
You need to memorize it.
You're given the other ones.
But not this one.
Not this one.
So this one you have to memorize.
So it's n over 2, and then it's a sub 1 plus a sub n. Now, a sub n is always the last term in the sequence. Now, sequences can go on forever, but usually you would say like the first 20 numbers, the first 30 numbers, whatever it might be.
Now, this is always an arithmetic series. So all your series are growing up by either adding or subtracting. So you need to know that you're only focusing on arithmetic series.
We'll do geometric, not now.
So you're always given different information. You just got to need to know how to work the formula.
So again, it's n over 2, parentheses, a sub 1 plus a sub n. Well, 10 over 2, parentheses, 12 plus 93. Bam, look at that.
Yeah, I made an easy one to warm us up. So if they give you your first term, they give you your last term, and then give you the number of terms, all you're doing is plugging it in and
Yeah. So then you
correctly
have
doing
5 times 105. Oh, look at me go.
Ooh, nice. Can you do that one?
Oh, I could have,
yeah.
but I stopped.
I haven't had enough coffee yet. So that sum of n equals 525.
The sum at n. Boom.
Okay? All right, we've been given different information.
Okay.
Oh, Miss Ozier.
Oh,
We
yeah.
haven't been given the last term.
Okay, but it says n is 20, so I can use my explicit formula to find the 20th term. So this is where you have to like build onto past knowledge.
Right.
So I can tell that my difference or my distance is a third. Okay, so I'm going to use that explicit formula, and I'm going to substitute the first term, the difference, I'm going to distribute, and I'm going to make everything pretty.
Okay, so what you just did was find what the 20th term is using your explicit formula. You need to know that.
Yep.
You need to know that you can work with whatever you got. So now you plug in the number of terms, the first term, the last term, and you do the math.
So this would be 33 thirds, which is 11, so 10 plus 11 is 21. 10 times 11, darn it, it's not
Ooh.
plus. Oh, 110.
So that sum is 110.
110.
Now, we're not saying that you can't write all 20 terms and add them up in your calculator.
I'm saying you can't do that. Don't
But
waste your
no
time.
one's got time for that. But if you can't remember any of this, that's one way to get a point.
Yes. If you are 100% lost, you can sit there and type every single one in.
And add them up.
But we will make fun of you.
Okay. So in this piece, I've been given the first term. I've been given the distance of the series and the number of terms. So again, I have to go after what that 9th term is.
Okay, so I'm going to use the explicit formula to find the 9th term, and I found out that that's 12.3, and then I substitute it in.
Mm-hmm.
It's that easy.
Yep. You just got to know what you're given and what variable you're solving for.
Like we said, the hardest part about this chapter is the notation.
Yep. Notation, notation, notation.
Okay, 3 halves to 3 to 9 halves to 6, etc., etc. So we're going up by 3 halves, or 1.5, same thing.
I used decimal.
3 halves is 1.5.
I'm judging myself
Same
right now.
thing.
Why did I use decimals? I think I was
judging you
getting
too.
tired.
So we have the explicit formula. We've substituted 9 in for n so that we can get the 9th term of the sequence. So now the sum of the series at that term is 67.5.
Yep.
Boom.
And you shouldn't be afraid of fractions. I'm really disappointed in myself right now.
Don't be afraid of fractions. It's easier on a computer to type in 1.5.
That's
than
probably
3
what I
halves.
was doing.
When
I
you're
was
doing
lazy.
a PowerPoint, it's easier.
Oh my god, it's a word problem.
Oh, I'm going to skip it. There's too many words.
Too many words. I'm not going to do it. Don't
At
do
least
that.
read the darn thing, people.
And underline things that you feel like are important.
This is math, not English.
Kurt has set up a college savings account for his son, Maxwell.
Hey, Max.
Okay, if Kurt deposits $100 per month in an account, increasing the amount he deposits by $10 per month each month, then how much will be in the account after 10 years?
Whoa. Okay. Well, the good news is that we're actually in the arithmetic series video, so you know that this is an arithmetic series. But you would have to be able to read this and say, okay, if I'm increasing by 10 each month, I'm increasing by a common distance. So really, you're just plugging into this
my
formula.
animations must be
Okay.
off.
That's okay. So working backwards, we need to figure out where it's going to be in 10 years. But you got to pay attention because it's per month. So it's not 10 would not be your n. 120 would be because there's 120 months in 10 years.
Yep. And you would have to figure out how much there's in this account on that last day of 10 years. So
Right.
that's why we're plugging in 120 over there to find that 1,290. Told you my animations were off.
That's okay. The 10 is coming from that's what you're increasing each month. Every month you're putting 10 additional dollars in besides the original. Okay? So 100, 110, 120, etc. Ha, see?
Yep.
Okay.
Way to go with those animations.
It's all right. They get it.
There's my explanation of the month stuff, too.
Yep. Yep.
Good
All right.
explanations.
Well done.
Ooh, Ace of Ben, look at that.
Okay, so now we know that is the last term. So that's how much we're going to deposit in 10 years on whatever month. So let's say it's December, okay? That's what's going in. So now we need to say, okay, if we put 100 in and then we added 10 every other time, and this is what we did the last time, that would be $83,400.
Way to go, Kurt, or Mike's, Max's dad.
Max's dad, yeah. But I
That's a good
mean,
idea.
honestly, depending on tuition rates, that might cover a year and a half, maybe 2 years.
Yeah.
Depending on the school. But okay. So, it's not to be depressing. That was it. Have a wonderful day, everybody. We'll see you in class series.